Hello, this is Bill Silverstein, Pennsylvania State Event Supervisor for the Science Olympiad Battery Buggy event, here to give you some pointers on how to run the event at a competition. Go. First, there are a number of resources available on the National Science Olympiad website, which you will need to download. Be sure you have the current year rules and reread them before competition. Also check the website for any rules clarifications or FAQs and print a copy for yourself. Next is the 2019 track layout, which you will need to set up the event. You will need to print out a number of copies of the team checklist so that you have one for each team at your event. And finally, you will need to download the most recent Battery Buggy event score sheet, an Excel file you will use for scoring the event. Additional resources which you should review and/or have on hand include 2019 Event Logistics Manual describing space requirements and other pointers, SO Battery Policy, which also includes guidance on wiring, the Calculator Guide, the Building and Tools Policy, in case any questions arise as to whether a car is student-built, and the Laser Policy. Students cannot use lasers in this event, but you will be using them for event timing. To set up for the event, you will want to arrive early, well before students start showing up for impound. Requirements for the room are described in the Event Logistics Guide, such as a wide, flat hallway, gym, or other open space such as a cafeteria, with adjacent space for impound of vehicles. Although I would note you do not need the large mass balance listed under supplies in the Logistics Guide, and I recommend more than the 2 to 4 helpers listed. I like to set up in a manner so that students have to pass the check-in scoring table to get to impound, as well as to the inspection table, and rope off the competition areas surrounding the 2 tracks and impound with caution tape. Leave plenty of space between the scoring table and the start of the tracks so that students at vehicle inspection and students setting up cars at the start line do not interfere with each other. The next thing to do is set up the track according to the 2019 track layout using 1-inch painter's tape, which is usually 0.94 inches these days. Note that there is no centerline tape. Beginning with the start point, which is a dot on a piece of tape, measure and lay out the half-meter line so that the near edge of the tape is at 1/2 meter. The line itself should be at least 2 meters wide. Next, lay out the 8.5 meter line in the same manner. The stop mark is then placed with a dot on a piece of tape located 9 to 12 meters from the start point. According to Rule 5A, the exact distance is in 50 centimeter intervals for regionals, 10 centimeter intervals for states, and 1 centimeter intervals for national tournaments. Finally, the bonus line is placed halfway between the start and finish, extending from the imaginary center line to a point 1 meter to the left. Note that the track does not have a tape center line. Here is an example track setup which is shortened for demonstration. To the right is the start point on a small piece of tape, and the half-meter line with timing laser that I will discuss later. In the middle is the 1 meter long bonus line with 2 full cans. The brand does not matter, but the size does. I found that a 15-ounce can met the rules requiring a 7 to 8 centimeter diameter and the appropriate can height. You will need 4 of these to run 2 tracks. To the left is the 8.5 meter timing line set up at 3.5 meters in this photo, and beyond that, the stop point on a small piece of tape. Timing systems are one of the areas where questions are frequently asked. Timing can be entirely manual or electronic with manual backup. The object is to accurately time the vehicle from when it crosses the half-meter line until it crosses the 8.5 meter line, or any extension of it, or until the car stops if it does not cross the 8.5 meter line. At a minimum, for manual timing, set up a small laser, such as a laser pointer, at a height of 17 centimeters across the 0.5 meter line and another at the 8.5 meter line. Use a USB-powered laser and small USB battery pack. When the vehicle passes these points, the vertical dowel will cross the laser beam, resulting in a flash easily seen by the people timing the event. It's a little harder to see in the video, so the following video pauses a second when the car crosses the beam. Ready? 3, 2, 1, go. For electronic timing, you will need either a manufactured or homemade laser receiver detector and a timing unit. I use a homemade Arduino-based system using 2 laser sensors mounted on stands. The bottom dot you see is the laser being detected. The top is a green LED showing that the laser is ready. The start and stop receivers are wired to a control box which has a third green LED and the word ready. After a run, the time reads out 1/100th of a second. When electronic timing is used, only enter one time on the score sheet. It is still important to use manual timers, a minimum of 1, but I use 3, in case the timer does not work, or if the car stops short of 8.5 meters, or curves wide and does not go through the timing gate. In addition to the materials listed, you will need volunteers. As many as 10 people can be useful to run this event. These include the event supervisor, someone to control impound, someone to check in teams, 3 timers, 2 track bosses, and 2 assistants. At impound, each team is given a team checklist to fill in team number, team name, and 2 student names. I remind students that they must impound the vehicle, batteries, parts, and practice log, and that no lithium or lead batteries can be used. If they are missing these items, usually the practice log or their 20-centimeter dowel, they can go get them and come back during the impound period. Once they are ready to impound, they are directed to the impound area to place their vehicle against the wall, not touching or blocking other student materials. The next 5 questions under construction parameters on the team checklist can be completed by the event supervisor either at impound to get a head start, or as each competitor arrives for their scheduled time. Note that the numbering on the left side of the page match rule citations. Every rule is important. The following highlight some of the areas of common violation to watch out for. The rules are very specific as to AA batteries only, non-lithium, and individual battery cells must be visible for inspection. You can have the competitors describe the stop and disconnect method to comply with Rule 3C. Note that when you measure the vehicle for Rule 3G, axles and other parts can extend outside of a 30 by 60 centimeter box. Only the wheels themselves must be within these dimensions. For Rule 3H, it is a common competitor mistake that the dowel is tall enough, but not close enough to the floor. When a team is checked in and the checklist completed through 3I, the team can select a track and move their vehicle and supplies, but not do anything yet. The track boss explains the 8-minute timing, reminds the team to notify the track boss when they are set up, but don't start the car, and tells them their 8 minutes are starting. At that point, competitors can set the inner bonus can, or ask for cans to be removed if they are not going for the bonus, insert batteries, make repairs, align and set up the car, then stop and notify the track boss. The 8-minute timer is paused. When the track boss and 3 timers are ready, the student is given a number 2 pencil and asked to count down 3, 2, 1, start.
Ready? 3, 2, 1, go.
The track boss restarts the 8-minute timer when the car starts and pauses it again when the car comes to a stop. Between there, 3 timers record the time from the half-meter mark to the 8.5 meter mark, the nearest 100th of a second. The track boss measures the point-to-point distance from the front of the dowel to the target point to the nearest 0.1 centimeters. It also measures the bonus distance between the cans. Then fill out the competition and run parameters for run 1. Note that in questions 5E and 5F, a vehicle that moves but does not pass the half-meter mark is a failed run, while a vehicle that passes half meter but not the 8.5 meters is a competition violation. A vehicle that does not stop using its own braking system, such as running into a laser or a wall, is also a failed run. Minute timing resumes when the team is told to pick up their vehicle for the second run. They must set up the second run and notify the track boss they are ready before the 8 minutes is up. Scoring is described in Section 7 of the rules. It is helpful to know the difference between what results in a bonus or penalty, such as an incomplete practice log, versus what places a team in a lower tier, such as a competition or construction violation. However, you do not actually need to do any of this scoring math. Instead, fill in the blue section of the Excel spreadsheet, which has columns numbered to match the team checklist in order. When you save the spreadsheet, it calculates all the scores, bonuses, tiers, and rank in the purple section. Teams are then rank ordered in the green section of the form. Be sure to carefully check all your yeses and nos, as these have a big effect on penalties and tiers. As each team competes, be sure to tell them if they have any penalties or tiering. Make sure they understand why, and remind them to leave their vehicle in impound if there is any inkling of a possible challenge or any need for the team or you to talk to the team coach about the scoring. I hope you find this video helpful. I also recommend the 2017 event setup video for Scrambler, which you can find on YouTube. It provides good tips on setup of the room for any car type SO event. Thank you.